We're going to be looking at examples 5 and 6 in your section 3.1 notes. So in example 5, I went ahead and wrote out the more complicated side. The 2 sine x cotangent of x plus sine x minus 4 cotangent of x minus 2, and then all over 2 cotangent of x plus 1. And my goal is to get to this, the sine x minus 2. Okay, so I can see that in here. I can see a sine of x and a minus 2. I just really need the other things to go away. This is going to involve a little bit of factoring. So since we end up having 4 terms up in the numerator, we can do something called factoring by grouping. So you want to look at groups of 2 and see if there's anything that you can take out. So in the first group of 2, I can see that I can take out a sine of x, so I'm going to go ahead and do that. When I take out a sine x, I'm left with 2 cotangent of x, and then if I take a sine out of a sine, it's just like taking 7 divided by 7, so I need a 1 there. Okay, and you can definitely check by distribution that you go right back to that. Okay, and this next part, I can take out a negative 2, so I'm going to be left with 2 cotangent of x. And again, a negative 2, take out a negative 2 is going to leave me with a positive 1 there. And then this is all over 2 cotangent of x plus 1. Okay, so that's step 1 in factoring by grouping. Step 2 is to finish it. So you should have a set of parentheses that looks the same. So you go ahead and pull that part out. Okay, so once you pull that out, what you have left is the other grouping. So the other grouping is going to be sine x minus 2, okay? And that is all over 2 cotangent of x plus 1. Okay, one quick way to check, you could FOIL this out or multiply it out. You would go right back to the beginning problem, okay? We know that essentially we're done at this point. Since it's factored, we can go ahead and reduce anything the numerator and denominator have in common. So we can cross those out, and that leads us to the answer that we want. Okay, so we're done with example 5. Now in example 6, we can see that our numerator are the first part of the problem and the end, okay, or each side of the equation. They look pretty darn similar, okay? So one technique that we can do, because we can see a positive here between the cosecant of x rather, and 1. Here we see a negative. We can use something called the conjugate to help us out. So what the conjugate does is if you have x plus y, something like that, the conjugate is the same expression but with a negative sign, an x minus y. Okay, so on this one, I have a positive between my cosecant and my 1, so I'm going to go ahead and multiply the numerator and the denominator by the cosecant of x minus 1. As long as I do it in both places, I'm definitely good to go. Okay, I haven't changed the problem because this would reduce back to 1. Okay, so in the numerator, I have the cotangent of x, and then I have the cosecant of x minus 1. I know that looks good because I am going to want that in the numerator down here. Okay, the denominator, I'm going to go ahead and multiply that out. Okay, when you multiply that out, what happens is that the O and the I parts of FOIL cancel. So you're just left with the F, which is cosecant squared x, and then the L, which is a minus 1. Okay, all right, so we really need to be left with a cotangent down here in the denominator in order to be done. So the denominator is, needs to be changed to something about cotangent, but we have an identity that involves cosecant and cotangent that I'm going to write off to the side here. Okay, so we know that 1 plus the cotangent squared of x is equal to the cosecant squared of x. So that's not exactly the same as what we see here, but we can manipulate this equation. We can go ahead and subtract 1 over. Okay, so we know the cotangent squared is the cosecant squared x minus 1. Okay, so that's good news for us. So that tells us our denominator that we have can be replaced with cotangent squared x. Okay, at this stage, this part reduces. Okay, so we have one cotangent term on top, two downstairs. So when we reduce, we're left with the one cotangent down there and then the cosecant of x minus 1. And that completes example 6.